So we're going to go through post-tension construction and observation issues. My name is Brian Allred, obviously. If you have any questions that I don't answer during the seminar, or you just have questions that come up to you after the fact, please email me and I'll do my best to get back to you. My email address is Brian, my first name, @SenecaStructural, oneword.com. So if something comes up in general for post-tensioning or for this particular webinar, please let me know and I'll try to get back to you as quickly as I can. So moving forward, we're going to cover tendon layout, curving of tendons, anchorage zones, pour and delay strips, slip connections, which in my opinion is probably the most important topic. We're going to cover, I would say 99% of the phone calls, emails, or issues I get with cracking with PT has nothing to do with strength issues. Typically has more to do with RTS or restraint to shortening cracks, lack of slip details, or poorly constructed slip details. The cracks are, like I said, vast majority of the time non-structural, but they're aesthetic. Everyone can see them. The owner can see them. The architect can see them. The client can see them, or the people using the building can see them. And typically, unfortunately, anything that's cracked in concrete or masonry is a structural issue, even though it really isn't. But so those are the things I really like to focus on in terms of detailing. Conduit placement is an issue with all types of concrete slabs, whether it's rebar only or post-tensioning. But with post-tensioning, because we typically use thinner systems, it becomes much more of a prominent concern. Penetrations, integrity tendons, and lastly, discussion about elongations and what, as the engineer, we do with elongations. So if this webinar is at all interesting, I also give several other webinars through SK Ghost. My business partner and I, Dirk Bondi, wrote a book. It's currently in its 3rd edition, Post-Tension Concrete Principles and Practice. You can get it through the SK Ghost website. There's a hardback version and a ebook or a PDF version as well. So I realize Valentine's Day is coming up, and something maybe for your special someone they wouldn't be probably expecting, which is definitely this book. But the book covers pretty much everything from the undergraduate level class of post-tension concrete, which is the first 10 chapters, and then the last 9 or 10 chapters are construction related or industry related topics, you know, two-way slabs, podium slabs, one-way slabs and beams. So it pretty much takes you from day one into effectively what you would do as a practicing engineer using PT. Obviously there's a lot of numerics in there for the undergraduate program side of things, but there's also a lot of construction photographs, and most of the photographs you're going to see in this webinar come from the book. So if you are interested, please give it a look. So what it should look like in the real world, and in a global sense, for this is obviously a two-way slab example, everything in PT in terms of the drape of the strands, which we're going to focus on in this webinar, should be gradual. There should be no extreme peaks or curves in the tendons. Everything should be a very slight gradual up to a gradual down and so forth. So as you look across this photograph going left to right, you know, it's kind of hard to actually see the rise and fall of the tendons, and that's basically what you want to see. A little bit of elevation jump here. So if we look at this point, you can see the elevation is jumping, or excuse me, is higher here. It goes down a little bit, but it's a nice gradual parabolic profile across the system. So when I do observations, and at least in California, at least where I do most of my work, we try to go out and see every slab pour, primarily because it is complicated. And when you're working with post-tensioning, you know, little whoopses or little, you know, too severe tendons with 33,000 pounds per strand can cause cracking and blowouts. And obviously, it's the primary reinforcement to hold up vertical and a lot of times lateral loads. So obviously, you want it done correctly. But in general, when I go out there, I usually kind of just kneel down a little bit as far as I can go with my knees before they give out, and just try to get a nice general overview and making sure that it's a gradual, and just look for the oddities, not so much bring out the tape measure or the calipers, but just look for the oddities. But again, it should be a gradual profile going left to right. Now, in a two-way slab system, you have the uniform tendons, which we saw in the last photograph. In the opposite or perpendicular direction, we have the banded tendons. Now, the whole philosophy between banded and uniform is a whole different webinar. I give one for podiums and two-way slabs if you're interested. But again, the general consent or the general information on these slides is that you want to look at these elements and again see a generic, gentle, gradual profile of these strands, and just look for, you know, the oddities correctly. I typically leave the CGS inspections for the inspector to make sure it's 8 inches or 4 inches or whatever it's supposed to be. But in general, general gradual profiles of both systems. The nice thing about the post-tensioning with this aspect is because the PT and the band direction